Yeah, I'm sorry. That was the sound. That was my style of sound check. All right. Cool. Hi, everybody. Happy to see so many lucky faces here. I think I'm one of the only audio lectures here during the program, so it's always good to fresh up a bit. And everybody at home at Twitch, hello. My name is Eric. I work for Genelec as a business development manager. I'm based in Berlin, Germany. And mainly, whenever it becomes immersive, I do get involved. I have a quite long track record in immersive audio technologies because I was lucky enough to have overseen the first German Dolby Atmos mixing studio back in 2012 at Rotor Film. It was a cinema post-production that we have redesigned a complete new mixing room, so 85 square meters. And basically since then, I'm completely locked into everything that is immersive audio, and I've have quite also a long track record in music mixing in immersive. Since 2019, I run an own little studio in Berlin. And but today, I want to keep it as informal as possible and hopefully not to lose you and not to go too nerdy. If it becomes a bit too nerdy, please wave if you have any questions every time. And you can always have questions at the end of the session if it goes too techy into the detail. So as my session describing is designing an immersive mix room, first of all, what does it take to get up and running? Just a quick hands up. Who of you is familiar with immersive audio workflows or is considering maybe designing a studio or building something? Cool. Okay. So, and the rest of you, you're completely blank or you know a little bit about the formats? So? Okay, let's just start a bit on the top and from the scratch and get into it. And before we start actually thinking about building an immersive mix room, may it be for post-production, for broadcast, for music, in the beginning it doesn't matter for what application you're doing. First of all, we have to check what are the different formats available that make sense to use in a studio. And in this little overview, I'm just covering the most popular immersive audio formats and the ones that are really commercially known, knowing that there are tons of other formats, especially when it comes to research or academic environments. This is nothing for me. I'm the commercial guy. So that's why, of course, we have to name Dolby Atmos. That's the longest and oldest format commercially available since 2012. Sorry. It's a hybrid format, so that means it can contain objects and regular channels. I hope you know a little bit about the formats and about the technology of object-based audio. But for us, on the commercial side of things, it's always very important, where do we find these kind of formats in the industry? And of course, it's in cinema, it's in home cinema. But now lately, broadcast is getting more and more popular to distribute content in Dolby Atmos, such as the Eurovision Song Contest, big sports event like Olympics or Soccer World Cup, things like that. Music, probably the biggest buzz at the moment, latest since Apple Music joined the club nearly 2 years ago, supporting Dolby Atmos on their streaming service. But now in more and more automotive environments where people can actually experience Dolby Atmos in a car, like in Volvo, Mercedes, Lucid cars, and many, many others as well. So that's why it's quite interesting for us on the production side, where do my customers can hear this actually? Another format that we have to mention, Oro 3D. Although it was a bit up and down in the last couple of months with Oro 3D, they are back in game. And they are very interesting because they are more or less mainly channel-based. There is an object-based addition to Oro 3D, but that's where we know them mainly from, is from the channel-based part. And of course, you find it in cinema, in home cinemas, a little bit in broadcast, not that much. But music is actually a field of application, basically, where Oro 3D could be very interesting. Local hero in Norway, Morten Lindberg, you probably know him all. He's one of the persons who lives and breathes in this format because his microphone setup that he's using for capturing music has been designed in an Oro 3D layout. And another format, very important, especially in broadcast, not so much in Europe yet, mainly in Asia, in Brazil, etc., is MPEG-H. MPEG-H is a development from the Fraunhofer Institute in Germany a couple of years ago. And MPEG-H, why it's important for me and for us, it's because MPEG-H is basically the technology layer of the 360 reality audio format that has been introduced by Sony a couple of years ago as a competition against Dolby Atmos, more or less. So this was just a very, very quick run through, in my opinion, the most important formats, knowing that there are tons of others as well, just to be complete. And let's have a look on the speaker layouts. So how many speakers do I need? Where can I place them? So the next part of the presentation will handle a bit about these topics. So Dolby Atmos, because it's the most popular format these days, I'm going to cover this first. In home cinema applications, which is there for music work, but also for post-production when it comes to video-on-demand things. So like if you wanted to work for Netflix or Amazon or Apple TV, it's all the home entertainment section of Dolby Atmos, which is not the theatrical version. And the most common speaker setups are somewhere between 5.1.2 up to 9.1.6. And actually Dolby Atmos home entertainment can address up to 22 speakers. And this is scalable. So depending on the size of your room, it's an amount X of speakers that you would install in this case. One very important thing for Dolby Atmos home entertainment, you don't need any kind of certification for your room and for your studio to be up and running to make commercial work. The only thing that some clients might ask you is what your speaker system is, because if you want to work for Universal Music or Netflix or these kind of suppliers, you have to have a 7.1.4 speaker layout or bigger. That's the only criteria that they come up with. Looking at Auro 3D, the speaker layout is a bit different because Auro 3D works in 3 layers, as you might know. So we have one layer on ear height, we have a second layer on 30 degrees, which is mainly in the corners, above the original speakers that we have on the lower plane, and then there's an optional voice of God mono source just above the audience. The voice of God is what they call it. And why Auro 3D is so important and so interesting is because the majority of people is using it in the channel-based division or section, that microphone setups who have the amount of microphones compared to your speaker system can be used right away, basically without mixing. So that microphone for that channel that you're capturing can go straight onto the speaker. So that's why for Dolby Atmos, you always have to do something. You have at least address it or create an object or put it in a certain place. But that's why Auro 3D, from a technology point of view for microphone setups, is an interesting setup. All right, let's speed up a bit. Let's check what's your application. So do I want to work in Dolby Atmos? Then we already heard for Netflix and video-on-demand things and music, 7.1.4, which is like a good reference layout, speaker layout to start with. Or shall it be Auro 3D, somewhere between 9.1 and 13.1? Those are the most common speaker layouts. So 9.1 is actually nothing else than a 5.1.4 on the Dolby side and vice versa. It's just a way how to juggle the numbers around, but it says the same. So 9.1 means you have a 5.1 setup, a regular 5.1 setup, and then you have 4 height channels in the corners, basically. And 13.1 would be 7.1, and then have 5 plus the voice of God, and so on and so on. I'm not going to bother you too much with numbers. But the next one, which is totally different, it's different in terms of how to place the speakers, is 360 reality audio, the Sony format. Although the reproduction of this format is mainly for headphones, there is a recommended speaker layout that you can install in your studio that you need to work with or can work with. And this, as you can see already, it looks quite different to the other formats. So where Dolby Atmos and Auro 3D can be combined in one setup, plus more or less in terms of angling, Sony 360 reality audio has a different layout, because they ask you to have 5 speakers on ear height, another 5 speakers under the ceiling, like height of everything, and then 3 speakers in front of you on the bottom, and no subwoofer. Interesting. So, but yeah, it is possible also to use a Dolby Atmos setup to work with Sony 360, but this is their recommended speaker layout when you really want to make work for Sony. Let's have a little bit of a look on room sizes and the mixing position. And here I'm covering now only Dolby Atmos because that's where we have the most also documented data and also because the most popular. There is a minimum recommendation from Dolby that your room size should be, which is something like 3 by 3.5 by 2.4 meters. If you ask me, it's quite cozy. And I think it's a bit too small from my point of view. But anyways, this is the starting point. I mean, rooms can always be bigger. And actually, we were checking if it's possible to put an immersive setup in here, but unfortunately, it was not possible. Anyways, so those are two different ways how you can mount speakers. Either, and which is the ideal approach, put them all on a circle around you. This is the ideal setup. That's also what the ITU is recommending. That means every speaker has the same distance to you on the sweet spot and can be angled that way. Although we know that not all rooms allow us to build a round speaker layout, we mainly have like rectangle setups of speakers. Not a big problem, I tell you how we can deal with this. But these are the different ways how you can actually check in your room. Now, more important is, which speaker can I use? Of course, it's Genelec, but which Genelec speaker? But we have some handy tools here. For those of you who come later, I work for Genelec, so that's why I have to tell this. So we have some handy tools available that help us to find actually the correct speaker for my application. And the DART, the Dolby Atmos room design tool, is actually it's available on the web, so you can download this and put in your room sizes, length by width by height. You can decide where's your mixing position, and then it's a drop-down menu where you can check not only Genelec, but all other brands are actually available to see, does that speaker work, or is it underpowered, or is it too big, is it too small, just to get a rough idea, okay, where can I go? What do I actually need for my room now to set up? When we go one Genelec path further, we have a document that is called the Monitor Setup Guide. This is a very extensive document which talks about room acoustics and the basics of room acoustics and speaker placement. And what we also have printed is this little chart. So on the left-hand side, you can see actually all the models from Genelec that are available. And underneath and above, you see the distance that you can sit away from the speaker, and it gives you a very clear, like red and green light figure. Is that speaker within technical spec for my listening distance, or maybe not? And these setups together, so the Dolby tool plus this, will give you a very good guidance about what kind of speakers can I use for my particular room. When we look a bit at the speaker positioning, so where do I place the speakers now? In this case, again, talk about Dolby Atmos. But if you set up a Dolby Atmos home entertainment setup, you will be able to also work in Sony 360 and in Oro 3D. But this is basically like a good base for things. As we already have and know in stereo, is basically the left and right speakers are like up to 30 degrees left and right out of my center axis. This has nothing has changed with that. The side surround speakers, there's always like a window of angles that you can use, like within 90 to 110 degrees. Main reason is you might want to put your speaker on 100 degrees. There's a door or a window or something in your studio, you don't know. So that's why this window of angles allows you to actually move the speaker to the correct position to accommodate the ergonomics in your basically in your room. And the same approach is for the back surround speakers, 130 to 135 up to 150 degrees, so you get a good coverage behind you, and it's not too close to the side surrounds, so differentiation is actually quite good. And for the top speakers, that's the easiest task ever. You just draw a virtual line up, you go 45 degrees in the front, 45 degrees to the side. That's where you mount your speakers. Same for the rears. And this is, it doesn't matter how big your room is, these angles always help you to find the correct position where you have to place them at the end of the day. We did some demo calculations with Donato Maschi. He's a very famous acoustician from Italy. You probably have heard about him already. And we're good friends with him, and we decided to create a couple of demo layouts. Okay, hey, to better understand, I have maybe a room with like 18 square meter. It's a good size room. What kind of speakers can I use, even if I have no idea about things? So we came up with a couple of calculations. So we ran the Dolby calculator. We have looked in our monitor setup guide and said, okay, cool. You have a room with 18 square meter. You should be good with these kind of Genelec models to go forward. And then, of course, this is always a bit tricky to say that this model will work. What we don't know is the level of acoustic treatment in your room. If your room is super dry and you have like 0.1 seconds reverb time, which is super dry, of course we might need bigger speakers because your room is so damped we have to put much more energy. If you have a lively room, which is a bit longer reverb time, then these figures might work. So it's always still worth checking exactly what's going on, but it gives you a good idea of where to go. And like a medium-sized room with 29 square meters would be this one. Then you find that these models that we have available in our portfolio can get you already to a very good result. If you have any questions about this or need assistance or guidance or something, please always contact me and us, and we're always happy to help according with your room sizes to help you calculate what the best speaker setup could be. Now, speakers and positioning and room size is always good. But one thing we always have to understand, and the more immersive we go, the more important it is, and this is about calibration. So tuning the speaker to your room. So that's why I've put in here, in an ideal world, the frequency of a speaker looks like this. Of course, we all know the speakers, that we buy them off the shelf, and they all have this nice little picture printed in the box. But this picture has been taken in this fabulous studio. This is not a studio, this is an anechoic chamber, dead room, no reflections, no nothing. So in here, every speaker is linear, of course. But the moment you take a speaker into the room, you might have reflections all over the place. Modes, reflections, anything that happens in the room. So that's why a frequency response of a speaker can easily look like this. And this is nothing dramatic. This is a real life example. It's nothing super problematic. So what we can see here is between 100 and 200 hertz, we have a big bump in bass. And this is mainly caused because that speaker is mounted very close to the wall. Yes, no problem at all. The golden question is, how do you compensate this? Going back, physics, second class for us, when we all were like 12 years old in school, the lower the frequency, the more omnidirectional it's been reproduced. And this has nothing to do with any speaker brand. This is just physics. And as our own R&D director always says, and that's a quote I always have to mention, is physics is always at version 1.0. There's no development in the versions of physics, so we have to work with it. So the lower the frequency gets, the more omnidirectional it radiates. That means we always have an increase in bass. That's all fine. We just have to make sure to compensate for this. How do we do this in Genelec with our technology? We have a big portfolio of speakers that we all can name to the SAM family. SAM is actually an acronym for Smart Active Monitors. You might have heard about this already. The way how it works is very simple. We have a software running on a computer, either on a Mac or on a PC, and the software is called GLM, which is the Genelec Loudspeaker Manager. And from there, we have a little USB interface connected. Very simple, doesn't take any load. From that USB interface, there is an Ethernet cable, standard Ethernet, going into every speaker, no matter how many you have. Can be up to 80 speakers and subwoofers. This is there to communicate with the speaker. So now our software is able to talk to the speaker, because every speaker has DSPs built in from the SAM series. On the little GLM network adapter, we also connected a measurement microphone, so we can do the calibrations. And there's an optional remote volume controller as well, because GLM can actually work as a full-blown monitor section and monitor controller. Just my microphone is just disappearing. 1 second. And very interesting is that we can actually control up to 80 speakers if we want. So 80 speakers is a good number for any immersive setup, I would say. We saw the filter curve of the frequency response of the one speaker uncalibrated. And we said, okay, with that technology, we're going to accept the challenge. Let's see what we can do with that. So the way how it works within GLM is very simple. Every speaker is playing back a sweep, and this sweep we're recording. And this, in this case, is the red curve that you see here. It's nothing dramatic, just have too much bass and a little bit in the mid-range, probably a desk reflection or something. And what the software then is doing, it's analyzing the sweep, and it's applying filters to this, which is the blue curve, trying to get the speaker as close to linearity as possible. Although we all know linearity only exists in an anechoic chamber. It doesn't exist in any room. No matter how good the room is, you have room influences. So what are we doing in this calibration? So first of all, we do a frequency response calibration. That's good. But much more important, especially when it becomes immersive, is level adjustment. When you think about working in immersive, or even in 5.1, you have to make sure that every speaker is reaching your listening position at the same volume. Otherwise, the whole acoustic picture would be falling into one side or another. And every speaker has to reach the listening position at the same time. Now, as I said in the beginning, we have a round circle around us in the listening room. That's perfect. Then probably there's no time of flight correction needed because every speaker has the same distance. But the moment you have a front row or you have a speaker maybe just a little bit above because there's a door, and then in the rears you put it at 148 degrees and not 136, something, you always have different dimensions and different distances from speakers to the listening position, and GLM is all taking care of this. Because with that sweep, we know exactly where the speaker is, how loud it is, and what the frequency response is. And then we calibrate this. As simple as that. And in a studio setup, it could look like this. This is actually a screenshot of my own studio, my GLM setup in my studio, where I'm running a 7.1.4 setup. And as I said, room response calibration, time of flight, which means distance of the speakers to the listening position to align this. We're doing a volume calibration. If you have big speakers and if you have small speakers, the bigger speakers have a different system volume than the smaller ones, so you have to align this. And this is all taken care in GLM. And, very important, also bass management. Bass management, you probably all are aware of this. If you have a speaker that is not capable of reproducing enough SPL or enough low frequencies, you can combine it with a subwoofer and use that in a combined system where you define a crossover frequency, and then everything below the crossover goes to the sub, everything above goes to the speaker. Right. All these things we take care in GLM. So, that was the nerdy part. Now we get to the fun part. And this is my other hat that I'm wearing. This is talking now about Dolby Atmos music mixing, basically. As I already said, unfortunately, I cannot play any examples here. I mean, I can, but maybe not. And, but still, I have a session with me. I can give a little bit a run through my workflow that I'm using. I'm working in Pro Tools. But first of all, I wanted to show you where I mix. So this is my studio. It's my own studio. And I'm using, of course, Genelec, surprise, surprise, all around. And it's a 7.1.4 speaker setup, Dolby certified room. And it's very simplified. I'm using Pro Tools as my main software. I'm using the Dolby Atmos production suite. I don't know if you're aware of this. This is the software-based renderer that is sitting on the same machine. I also have it installed here. And my whole studio is Dante-based. So everything is Dante or digital, basically. So my computer is outputting Dante, audio over IP. And then I have a converter from Digital Audio Denmark that is converting Dante to AS EBU and I'm feeding my speakers digitally with AS-EBU. Another interesting thing is, as you can see in my studio picture, the rack is on the right-hand side, built into the wall, and from there I'm running cables all around going to the rears. And because I have wired everything digitally with AS-EBU, I have saved 200 meters of cable. Because with AS-EBU, as you might know, it's always 2 channels per cable, so you can daisy chain. You go into one speaker and from there to the next speaker. So you're feeding 2 speakers with just 1 cable. Very simple, but sustainable somehow. Now, when we go a little bit into mixing workflows, especially, I'm the music guy. I used to work in post, but I was lucky enough to escape, so I'm working in music mainly. So I have daylight, as you can see, one of the biggest differences compared to a post-production. I'm usually following a couple of mixing concepts first. I'll think about what are the different mixing concepts. So I would say 95%, unfortunately, at the moment, is still mixed in Atmos, in this case, that has already been mixed in stereo or is about to be mixed in stereo at the same time. That means from that project, from that producer, artist, we usually get in touch and we get something we call stems. Stems is just basically multitracks, pre-mixed multitracks, where main decisions have already been made, like EQ, compression, and volume. So when I put up all those stems on 0 dB fader in Pro Tools, it sounds like the mix, not like the master. And for catalog products, and the older you get, and very popular thing at the moment, Beatles, George Harrison, Elton John, all these kind of living legends, basically, all the content had been recaptured digitally, so because it was still on tape, or at some point it might have been digitized, but they had to remix the stereo first in order to do Dolby Atmos. Where with frontline projects, so projects that are about to be done right now, is simple because the project is already open. You can talk to the producer and get the correct stems to work on it. The second case is the one that I prefer, of course. Like every mix engineer, we would prefer to first mix in immersive and then do all the stereo work afterwards. And I was lucky enough to do a couple of projects first in Atmos, which is great because you take different decisions. You cannot say if it sounds better or worse, but you know that you're taking different decisions because you're working straight away with this whole immersive, nice setup around you, and you're not restricted to listening to a stereo master to show, okay, how close am I with my mix now compared to the stereo master that already exists. And then what we then did is basically we down-mixed the Dolby Atmos version to stereo, and this went then into this mastering, to a mastering engineer, and that was then the delivery for stereo. But the main thing was mixing that thing first in Dolby Atmos. Now, what are the main challenges when mixing in Atmos? There's no mix bus. You probably all are aware of this, that Dolby Atmos can have up to 100 tracks instead of just 2. So all the bus compression that we all so love in music doesn't exist in Atmos. Well, it exists, but not so easy like in stereo. So that is a big challenge. Another big challenge is the user experience. So we probably in this room, we know about this. We have heard Dolby Atmos. We have probably also heard it in a nice studio environment. But our users or our consumers, they probably have either, if they heard it, probably they maybe heard it on a headphone, or they maybe heard it on a sound bar or on a smart speaker. Not many of them have heard it in a good calibrated studio, unfortunately. But that is a big challenge, because the mix that we're doing has to translate to all these different playback scenarios and still has to work in a smart speaker. I mean, that it stands good in a car, I can assure that works nicely. I was lucky enough to listen to my mixes in a Maybach. That works. Not everybody has a Maybach at home. But what are the main advantages of mixing in Atmos? First of all, we have an increased dynamic range. An immersive mix done in Dolby Atmos, or also other formats, is much more dynamic because we have to send out a track that is not louder than -18 dB LUFS. I don't know if you're familiar with loudness in the stereo music world. I mean, you get everything up to -4. And this is, I don't see the point. But in Atmos, the good thing is this loudness specification is done by Universal Music, Warner, Dolby, and everybody's following it, which is great. So if you have a piece of classical music, or you have a piece of thrash metal, or EDM, whatever, everything is following -18 dB LUFS. That's already a good thing. I think that's a good advantage. The next thing, why it's an advantage with Atmos, is basically this whole object-based workflow. And this is one point that I talk to people, even if they don't want to hear about Genelec, but setting up a studio in immersive, no matter what format we're talking today, it's a future-proof investment, because we then have a room where we can do any kind of object-based content in the future. It doesn't have to be Atmos. It can be something. It can be, we don't know what's happening in 5 years or 10 years, but at least we have a room that is object-based ready, because we have it equipped in a standard environment. And that definitely is an advantage to today. Just do it at one point. And also at the advantages, I have put the user experiences. As much as we have to worry about where people listen to it, the more we can be happy that people can listen to it in Atmos, because there's so many different scenarios where people can listen to it. If you remember the 5.1 music days, how many people have heard music in 5.1? Probably not many. One of the main reasons is you had to have 5.1 speakers perfectly aligned and then sit in the sweet spot to experience it. But as you might know, I mean, left and right speaker at home, 90% okay. Everything else, Wild West. Oh, there's 3 more speakers. Let's put them next to the cat's basket there. So it's impossible to play back something correctly in 5.1. Dolby Atmos is a different thing, because it's scalable. It can go from headphones up to full-blown speakers. So that's why it's also an advantage to work in this format. As much as it's difficult, it's also a big advantage. That was my keynote. I will now go into a session, and I think you made it till here. And the thing is, because we're in Norway, I brought a project from a Norwegian band that you might be aware of. It's actually, if I'm correct, it's the only Dolby Atmos mix that exists of Röyksopp. And it's a remix from Rodriguez Jr. And because I work very closely with Rodriguez Jr., I got to do this in Dolby Atmos. And it has been released last year in November. It's also on Apple Music, on Tidal, on Amazon. It's on Mobile Records. It's a Berlin-based record company. And I just basically brought the whole project with me. Let me just do this like that. So I have Pro Tools, and I have the Dolby Atmos production suite running in the background. Have you seen this before? No. Good. Okay. So just a very quick intro how to get this whole beast to work and to play music. We have tons of tracks in here, which are not very important right now. But one thing is important, because Dolby Atmos has to have a rendering unit. Because the renderer, in this case, it's software-based. It also exists hardware-based on a special machine in bigger studios. This software is the only piece of gear that knows how many speakers do you have installed, where are they, and how to drive them. So what kind of elements shall I play on which speaker? In Pro Tools, I just have tons of tracks that I'm sending out to the Dolby Atmos renderer. In the renderer, the composition has been basically done for my room and will be played back on the speakers. So that's the signal flow from Pro Tools into the renderer, and from the renderer to the speakers. That's always the chain that you have to follow, otherwise it would not work. If you're using something like Logic, or Cubase, or Nuendo, or Fairlight, the Dolby Atmos renderer engine is built into that software. So you don't have to use that workflow that I'm doing. This is a pure Pro Tools thing, as usual. Pro Tools is a good thing. It's always a bit later with some developments. Anyways, so there is something that is called the Dolby Audio Bridge, which takes all the audio from Pro Tools and sends it out to the Dolby renderer. And then in the Dolby Atmos production suite, I do have, as you can see here, the Dolby audio bridge as an input. And in this case, I have just my headphone cable stereo, binaural. Don't know how this sounds here. Anyways, we better not listen to this. And this then drives either your speakers in your studio or your headphone that you might have with you, because the Dolby Atmos rendering unit can also play out a binaural version. Have you heard about binaural? Does that ring a bell? It's basically a virtualized 3D mix for headphones. So this is all part of the food chain, basically. Now, once we've done this, let me just turn off the volume here, we can start to organize the Pro Tools session. And as you can see here, this is the amount of stems that I got for this song in this particular case, something like 30 stems, 35. It's not that much, but can be lucky if you get more than 5. Because sometimes you just have, sometimes even 3 or 4 stems, which is a playback and an a cappella, and then, okay, let's do something. It's difficult. I just color everything in my favorite color scheme, so all my drums are basically blue. My bass is brown, synth is orange, and so on and so on. And there are some lead vocals and some background vocals and effects down here as well. And this is my secret sauce, I'll show you later. Right. So what I'm doing then, and because I have a little bit, maybe a special workflow, but many music mixers use that similar approach now as well. I'm not using what we call the bed. So if you know, in Dolby Atmos, there is 2 ways of how to use channels. So the first 10 inputs of your mix are reserved for what we call the bed. The bed, B-E-D, but not bad, bed, is a 7.1.2 channel-based layout. And this is a little bit a traditional thing that comes from the cinema style in the beginning of Dolby Atmos. Many mixing consoles, like the Harrison, the Neve, the SSL, they all used to work in 7.1. Now with Atmos introducing ceiling speakers above the audience, they just simplified it by just adding 2 channels for everything ceiling left, everything ceiling right. And in the bed, no matter how many speakers you have installed on each side, they will all play the same source because it's an array of speakers. On the opposite, or on the addition, is objects. And objects are completely placed, can be placed completely free in 3D space. An object is determined just by a sound source, mono or stereo, no matter what it is. Can be a piece of vocal, can be a bass drum, can be a sound effect, anything. And what the software, in this case Pro Tools, is adding is metadata, so positioning information. Where do I want to hear this object? And the big advantages with objects is that you get a much more precision in the surrounds. Whereas with a bed, when you send something to the left surround speakers in a cinema now, not in music, you have like 5, 6, 7 speakers playing back that content. When you use an object, you can pinpoint it to every speaker. That's the big difference between using the bed and the objects. Now fast forward and just skip all the film post-production stuff coming into music. Many people, like we tend to use only objects and not the bed. There are many reasons why we do this. One of the biggest reasons is that we believe that the localization on headphones is more accurate when you use objects rather than using the bed. This might be a bit esoteric, but a lot of people think this. And in my personal case, I get like 30 to 40% less revisions since I changed to a complete object-based workflow. So even that was enough for me because every revision is time and it's... Anyways, so that's just the background information of objects versus bed. I'm just looking at the time. I don't want to spend too much time. We can always take this offline. But the biggest difference that I'm using is, in my session, I don't know if you know Pro Tools and Atmos a bit, so we have the chance to route here a straight bus, and here's where we do the objects. And this is how we do basically the panning in here. So this is now panning in Dolby Atmos because the orange box is ticked, so now this track is an object. And if I turn around this one, it'll be reflected. Let me just put play, and then you can see just how it looks like in here. So this down here is basically a three-dimensional visual helper where all your objects in 3D space actually are, and if they are static. In this part of the mix, it's mainly static. A couple of things are moving, not much. A couple of things are coming in here now. And this is definitely a very big helper when you mix, because we don't have left and right channels anymore. We have a lot more feeds that we need to play back. So that's why we have to overcome the thinking of mixing in channels. We have to think about mixing in space. And this is, I think, the biggest mindset change that we do when we mix in immersive, is that we don't have to mix in channels. We don't know how many channels people have at home in their reproduction system. As I said, they might just have a sound bar. But this can always be reproduced anywhere else. So this is just a visual representation. And this metadata is all created, in this case, in Pro Tools, because it's just standard pan automation, panorama, basically. It's very simple. Let me just check if I have something in here. So this is just a little lead that is coming up. And as you can see here, there is a little bit of pan information. It's not much, but you can see the bubbles flying around here. And this will be translated straight away into the Dolby renderer. So the pan information that I'm creating in Pro Tools are transported to the renderer over Ethernet, and the renderer is then reproducing it, or rendering it, onto my speaker setup. That's the whole miracle. That's the whole drama at the end of the day. One important thing in my workflow is, because I'm working completely object-based, I do still have, sorry, it's always with the glasses and the microphone. I still do have like a fixed channel-based layout, like a kind of bed, but object bed. So if I have a sound that is going into I have a very big bus structure here, front aux. So if I patch something to a front aux, it will go to left and right. No drama, just left and right only. If I patch it to the center aux, it will go to the center speaker. And that's how I've basically built all my speakers that I have as direct, basically patch feeds where I can route something in. The big advantage of this, that I can actually double things and spread things out. For example, I did it for this synth. As you can see, it's going into front aux, left, right. But still, I have engaged a side aux here, so it goes also additionally to the sides with that level. Or it can also go to the rear aux, so for the rear surround speakers with a different level. This is basically how you can easily distribute elements in 3D space without moving them around. Because when I move around an element, it goes away somewhere else to appear on the other hand, on the other side. So it's always either or. But if you want to kind of spread out things and make something big instantly, that works. Now, the scientific academic people will always claim, phase issues, and you can't do this, and double. Yes, you can. If it sounds good, it's right. That's my approach. I'm an emotional mixer. I'm not an academic mixer. And if I listen to it and if I like it, then I leave it. If I hear some phasing, of course I change it. But I'm not so scientific in this. I just try to get things done. And I think my mixes are quite open and spread out. But that's very simplified the way how we work in Atmos with distribution of sounds. So either you take an object, you move it around, or you put it on a certain spot and leave it, or you can put it on straight into discrete speakers with this way workflow. Can you still follow me? Yeah? Good. Before I close it, the last piece of a mix is always, I would love to hit play and show you, but go to Apple Music and navigate and you'll find this mix. The last bit of things is always this delivery of a mix. And because we always have in the session a stereo master as a reference, which is up here, we have to match the stereo. As I said in the beginning, if the stereo already exists or is in the process of being made, we have to match the stereo. We cannot go wild and do something else and just flip the whole mix around where people have been working for years on it, and we just come in and say, hey, let's do something else. So basically what we also have to match is the color and the tone and the compression and the style of, because in stereo, as we know, mix bus compression, there's a lot of effort coming into that process of the creation of a song. So we can do basically similar things, but we just have to duplicate it by 59, and then we have 118 mix bus compressors, and this is what I have basically here in my session. So what I do, for every object that I'm using, I have done a master track for every object, and I'm using 118 objects, so that means I have 118 master tracks. And on every master track, I do have a saturation plugin and a limiter. That's basically it. So this is basically my mix bus, my Atmos mix bus style. And what I did, and this is why I like Pro Tools compared to Logic, I can link many, many tracks, and I can link the processors. So if I turn around on my object 1, 2, something on the saturation plugin, it'll be reflected on all the other 116 objects at the same time. So it feels like stereo mastering, but it actually works on the whole Atmos track. And this is, I think, the biggest mindset change that we all have to go through when we talk about an immersive mix versus a stereo mix. Because in stereo, it's simple. You just dump tons of plugins on your stereo out, and then you're good, more or less. I mean, very simplified. But in Atmos, you have to think differently. And what I'm doing, and that's my secret sauce, I'm using a pre-fader send from the stereo master to trigger the compression in my saturation plugin. So whenever in the stereo master something kicks in, it always kicks in the whole Atmos mix at the same time. That's why the mixes have to be cut very precisely over each other. And I would love to hit play and show you before and after, but you have to trust me, it really works. And but that's the whole secret behind that. The rest, obviously, is, get some files, get some projects, and start experimenting. It's the only thing how you can get there. And this is basically my little workflow in a nutshell. Time-wise, we're good? Are there any questions? Not everybody at the same time, please. One after another. Okay, cool. Then let me just close it here. Thank you very much for being here, for listening to my monologue. And if you have any questions, I'm around the whole day and tomorrow. We are at the Benham stand, where we represent Genelec. And if you have any questions, please pop by, say hi. And thank you very much.